Hello, my name is Aurik Umaima, the first writer of the article entitled Analysis of the Resistance to Crack Propagation in Scientist Specimens Printed in ABS. To do so, we have designed two approaches. The first experimental to determine the critical stress intensity factor, and the second numerical to predict the possible paths of crack propagation. The first step in experimental approach is the realization of scientist specimens by FDM technique. We therefore choose to work with two types of test specimens. The first adopts aligned layers with parallel filaments, while the second adopts coursed filaments between layers, from which we obtain the following straight strain curves. We found that the damage mechanism for the configuration 1 seems to be affected by the Raster angle. Indeed, when the angle created between the filaments and the axis of the applied load is low, the tensile stress is better with a 3.64 megapascal meter root for the critical stress intensity factor. This resistance decreases with the increase of the Raster angle. For the configuration 2, the curves have a near mechanical resistance with an order of magnitude of 3 megapascal meter root for the critical stress intensity factor. However, the case 45 degrees minus 45 degrees is clearly distinct by a large phase of non-linear behavior. Turning the numerical approach, for the first configuration, the crack propagation followed the Raster angle, which was confirmed not only by our macroscopic observations, but also by our numerical simulations. And by analyzing the damage phenomenon of this configuration 2, we observed two types of failure. The first type is the separation of adjacent filaments, and the other is the filament failure following the largest Raster angle. Except for the case 45 degrees minus 45 degrees, the crack propagates almost straight.